Let's determine if this integral converges or diverges. So let's give ourselves a rough idea of what the function looks like. The function that we're trying to integrate here is 1 over x minus 1 to the 2/3. So this function will have a vertical asymptote at 1. And no matter what x value you have, after you square it and then cube root it, it's going to be positive. So it's going to look something like this. Doesn't have to be perfect. It just gives us a rough idea of what's happening. And I want to integrate this function between 0 and 3. So the integral between 0 and 3 of this function has to be broken up into 2 different intervals. So we will integrate from 0 to, let's call it alpha. And then I will send alpha to 1 on the left-hand side. All right, so once I send alpha to 1, it will fill the rest of that space. And hopefully it converges to a finite answer. And then I will also need to integrate from something that we call maybe beta over to 3. And then we'll send beta to 1 on the right-hand side to fill that space. So we will take limit as beta approaches 1 on the right-hand side. Okay, so here we have limit as alpha will get sent to 1 on the left-hand side. Pause the video now, find an antiderivative for 1 divided by x minus 1 to the 2/3. So you should end up with 3 times the cube root of x minus 1, which is going to be evaluated between 0 and alpha. And we will add limit as beta will approach 1 from the right-hand side, 3 times the cube root of x minus 1, evaluated between beta and 3. So I can take this 3 out and look at the limit as alpha is approaching 1 from the left of the cube root alpha minus 1 minus the cube root of 0 minus 1. And I can also take this 3 out because it's a constant. So I can write it as 3 times the limit as beta will get sent to positive 1. The cube root of 3 minus 1 minus the cube root of beta minus 1. Okay, so if I send alpha to 1 from the left-hand side, then alpha minus 1 becomes 0, and the cube root of 0 is a 0. This term is a constant, so it's not involved in the limit. 0 minus 1 is a minus 1. Cube root of a minus 1 is a minus 1. So here we have 3 times 0 minus a minus 1. Here we have 3 times. This front term now is the constant. So 3 minus 1 becomes a 2. So I have the cube root of 2. And then if I send beta to 1 from the right-hand side, as beta becomes 1, beta minus 1 becomes 0. Cube root of 0 is 0, so minus 0. Okay, so let's see what we get. Inside the front brackets, I've got a positive 1 times a 3, so that gives me a 3. And inside my second brackets, I have the cube root of 2. So I've got 3 times the cube root of 2. Okay, so that's a final answer. That's finite. That is the area underneath this function between 0 and 3. So the integral does converge.